Virtual device contexts is a feature that allows us to provide physical and logical network segmentation. I like to call it Layer 1 virtualization because of the fact that we're taking a physical switch and dividing it up into multiple virtual switches. Each switch can have its own personality, its own VLANs, its own processes, its own routing protocols, its own IP address scheme, or even the same IP address scheme as one of the other switches. Of course, the VDC actually virtualizes a lot more than Layer 1. You could say that it virtualizes Layer 1 through Layer 3 because you get all new VLANs, all new routing protocols. Everything runs like a separate switch inside of the VDC. The current NXOS software allows for 4 VDCs plus an admin VDC. We like to call this 4+1. The 4+1 VDCs are supported on Supervisor 1 and Supervisor 2 modules for the Nexus 7000. We also have the capability to support 8+1 VDCs, and this is allowed on the Supervisor 2E on both the Nexus 7000 and the 7700. Previous to allowing the +1 or the admin VDC, we were only allowed 4 VDCs, and you may still find that in environments today running older versions of code. It's important to remember that for each VDC, they have independent processes, independent interfaces, and each VDC is considered a separate switch. And they all have different VDC numbers, so you'll have VDC 1, VDC 2, and VDC 3. Here is an example of how these VDCs might be laid out. VDC 1 might be the admin VDC, which has no interfaces but does have special privileges. Administrators that can log into the admin VDC have the ability to change other VDCs and even suspend and reload those VDCs. So it's very critical to keep access to the admin VDC limited and only to the people that need it. You can also reload the entire Nexus switch with all the VDCs from the admin VDC, but from the other VDCs, you can only reload those individual VDCs. There's also role-based access control, which controls who has access to individual VDCs or the entire device. In this use case, we have 3 other VDCs defined. We have a core VDC, which includes interfaces 1 through 16 from Module 1. This core VDC houses all of our core routing and switching capability. In this example, we're also using another VDC for OTV. In that VDC, we have interfaces Ethernet Module 1, 17 through 32. Because this is an OTV VDC, we're going to assume those interfaces are M-card interfaces or F3 interfaces, because those are the modules that support the OTV functionality. In VDC 4, we've created a specialized storage VDC, and this allows us to support Fiber Channel over Ethernet inside of the Nexus 7000. This takes a specialized VDC with specialized interfaces, for example, from an F-Series card that can run the FCOE feature set. Ports are allocated on a port group basis, and every card is a little bit different. In some cards, you may have to allocate ports 1 through 8 to a specific VDC because they are tied together through the ASIC, whereas with other cards, you may be able to allocate ports on a port-by-port basis. Please remember that you cannot communicate between the VDCs internally on the device. In order to communicate between 2 VDCs on the same device, you must actually use a physical cable to connect ports in one VDC to the ports in the other VDC, and then route or use Layer 2 to share information between them. Hopefully, you can see the power of the Virtual Device Context feature. Please join me for the next lesson, Understanding Port Channel Functionality.